So these maps shows the likelihood of finding electrons in a region, first of all. The counters are lines of equal electron density. This map shows that sodium chloride, the ions are arranged in a regular pattern. This is the pattern. Smaller, bigger, bigger, smaller. And then the chloride ions are larger than the sodium ions. As I've already discussed to you, if the ion is negatively charged and there are more electrons in it, it will give a bright spot. So this is a bright spot. This is chloride. The ion is smaller in size. How many electrons are there? Around 10 electrons are there. It will give a dim spot. So this is a dim spot. This is a bright spot. So the more the number of electrons, the brighter is the spot. The less the number of electrons, less are the spots. One thing. Secondly, if you see the ions, they are not connected to each other actually. The ions are quite apart from each other. Now see the ions, both the ions are away from each other. This is sodium, Na, positive. See, all the lines are in itself. They're not touching the other one. And this is chloride. So this shows existence of the ionic substances. The ions are discrete or separate because the electron density falls to 0 between the ions. So there is no electron density in between. That's why they are separate. Are you clear with this?
Yes, sir.
So the space here, here and here, it falls to 0. This is the thing. The electron density map doesn't, however, show the degree of the ion, and so it is difficult to measure the radius of the ion from electron density mapping. You can't measure exactly how much was the size of the ion. This is one of the. Okay, secondly, physical properties of ionic compounds. They are having high melting and boiling points, and the reason for the high melting and boiling points are that they are having strong electrostatic force of attraction between the ions. The stronger the electrostatic force, the higher are the melting and boiling points. Ionic substances are non-conductors of electricity when they are in the solid state. Because the ions are stuck on their position, they are tightly packed. They can conduct electricity when you dissolve them or they are in molten state. Now at that position, the ions are free to move. And one of the properties, they are brittle in nature. Brittle means you can hammer them into pieces or shatter them into pieces. Like sodium chloride can be easily broken down into pieces with a hammer. Right? And let us explain this. If we exert a little force, it will push the ion along the other ions, which are next and similar ions there. So there will be a force of repulsion between the like ions and pushing the layers apart from each other. Now if you exert the pressure here, so all the ions like this, these two ions are coming close to each other, they're coming close to each other and they're getting close. So a huge repulsion is generated. And then the ions are broken apart from each other. Okay, the third evidence which we discussed yesterday was the migration of ions or movement of the ions. Yesterday I've given an example. The color was green here in your book. So it is copper chromate, copper 2 chromate basically. The copper ions are blue in color and chromate ions are yellow in color. Chromate is having a negative charge, so this negative charge will take it towards the positive electrode, and copper is having a positive charge, it will be taken to the negative side. If we do the electrolysis of the ionic substances, we can see only for those ions which are having the color. We will see that the green solution is turning into two different colors or two different solution. A blue, something blue is moving towards the negative electrode, and something yellow is moving towards the positive electrode. Right? This is one example. Second example is of potassium manganate. In this potassium manganate, potassium ions are colorless. They are not transition, so they are colorless. Only manganate ion is going to show the color. So KMNO4, this manganate ion will start migrating. What is the charge on manganate? Negative charge is there on it. You can see this. So it will move to the positive electrode. And you won't be able to see potassium moving to the other side because potassium is non-transition element, so it doesn't show any color. You have any question, you can ask, please.
All clear, sir.
Okay. We will have a small break.